Okay, we are starting. Please have your seats, fasten your seatbelts. This is about Perl begat Perl. Now, the person who really begat Perl is back there, but okay. So what is begat? We all know. Anyone not know the word begat? Okay, you all know the word begat. Great. It's Perl. Begat is the biblical term for making a new generation. And in Chronicles 1, chapter 2, verse 20, I was begat. And I begat Bezaleel. I was begat 62 years ago. Tomorrow, my birthday. So on the cruise tomorrow, I want to hear happy birthday. Or was I begat 5,000 years ago? Whatever. Well, Larry, what was the what's the, how far back does that go? Okay, fine. I agree with you. You can't trust anything in the Bible. This talk is about Perl generating Perl, or really calling eval string. Who has never called eval string? Really? Okay, it's cool. I mean, that means that we have a pretty sophisticated audience here. I mean, I could skip through a lot of this stuff quickly. That's important. Okay, what is eval? It's a function of Perl that evaluates an expression in string context as Perl code. It compiles and executes the string of Perl at runtime, not compile time. So you can call it any time you want. It returns the value of the expression. It catches any syntax or runtime errors or die calls. History of eval. Lisp had eval in 1958. I was born in 57, so it's we're talking a long time ago. So it's not a new concept at all. Almost every dynamic language we know has some version of eval. There's a short list. And I found a Wikipedia article on eval, which I learned about Lisp having in 1958. I knew Lisp had it, but I didn't realize how early it had it. It's kind of a fun article. Not that you have to read it. Okay, so Perl 4 needed eval to do some complex data engineering. It had symbolic references, but it did not have hard references. So building up nested structures was very difficult. I wrote a Perl 4 project that did a data tree in a single array using symrefs and eval and all kinds of nasty stuff. So eval string versus eval block. Now, this is one of Larry's few mistakes. There's a need to just catch fatal errors and die calls, so eval block was put in for that purpose. And he called it eval because it sounded similar to the eval string, which is catching dies and fatals. But it didn't execute the code at runtime and execute at compile time. So that's the big difference. Syntax errors are reported with regular code time, and it should have been called a different name like try or something. Other languages have it. So it's a very different eval string. So eval, we all know, is evil. It's too easy to shoot yourself in your foot and other body parts. Whatever part you like the most, you'll shoot yourself in that. And it's not nearly needed as much as Perl 5 has hard references. So the whole thing of building a data tree is so much easier in Perl 5. But it's still useful. It's going backwards. There we go. Newbies feel it's a neat trick. I teach as a line you can use. I teach newbies you can't use eval or symrefs until you know when not to use them. It's they think, oh, I'll use eval. It's like the first thing they think of when they learn eval, they start using it. And symrefs, it's crazy. And neither one is usually needed, especially at newbie level code. So eval can bring out the stupid. Now, are you all sitting down? This next line is going to burn your eyeballs out. I was given this by someone on London Perl Mongers list, and it apparently is real code somebody wrote. And here's the best part about it. It's really fun. You could take out the eval, it still works. You could take out the system, it still works. You could take an eval in system, it still works. That's a great line of code. It's just, wow. That's some person did. I'm trying to think, what were they thinking? I don't know how they came up with doing this. Okay, they didn't know sleep was built into Perl. I got that. So why call Oh, so they knew shell had so why call he calls system? Great, okay. Why would he need an eval on top of that? Because system is like I don't. Maybe they thought system was another language too, and they thought eval would. But the system is in Perl here. I don't know what they're thinking, but eval is not always evil. Here's some 4 good reasons. So there's others to use eval string: convenience, do the impossible, S with lots of E's, and speed. So eval string for convenience. Who's ever loaded the module dynamically at runtime? I mean, it's a pretty common thing, but it's a real pain because it takes a class name only at compile time. You say require class name with no quotes or anything, it'll work, but it's done at compile time. And you want to have a database or something telling you to load up a polymorphic module, which I've done many times. You can't do that. So require could take a file name at runtime, but you have to take the class name and you have to among the quote the colons, the slash, append to PM, and maybe do some other things. That's 3 or 4 lines of code. Annoying. So it's much convenient to use an eval string, and this works beautifully. And I've done this many times. Ever seen this line of who's seen this line of code before? Yeah. Okay. So that's the standard way. It's even documented as a way of doing it. Okay. So it's not an obscure, don't do this kind of thing. It's actually in the documentation to require. Here, do the impossible. TR, which is a really neat operator, does not interpolate. So let's say you want to do a TR, but you want to have, select the text, the characters to be translated from one to the other. I say translated, not transliterated. Larry and I disagree on that one. So here, this works. You eval the TR, and you can interpolate the from string, the from characters, and the to characters. So you're doing the impossible with eval. Everyone get this one? This is really neat stuff you can do. This is one of the things where eval comes into play. You really want to do something that's tricky. Now, eval string and substitute. The E modifier. Who has never used the /E modifier in substitute? Never used it? Okay. And everyone else has used it? Really? Okay. That's cool. We all know what it does then. I'll go quickly. It makes the replacement part of the string a Perl expression and evaluates that and returns that value for the replacement. The expression's value is used as a replacement string. It's not exactly eval string because it's syntax checked at compile time. It's really more like eval block. But here's an example I use in template simple. The replacement part in this expression is a recursive call, which is really fun. Which means that this eval is calling other evals below, which parses the matched text and returns a string reference. So the first line, basically, there's the regular expression, include RE, and I'm using braces as the delimiters. So the bottom line is the actual return expression. I'm dereferencing the call to get template of $1, which is the part I just matched. And then I have the E operator, E modifier at the end, which means that the whole thing here is just a Perl expression. But this is not string eval. This is block eval, basically. But there's more. What about /EE? Anyone ever seen this? Well, someone played with it one time, and they found out it actually works. It was not intended, not designed, not anything. It actually works. The first E is as we described before. It's a block eval. The second E is actually a string eval of the return value of the first E. And it has its rare uses. Here's a code one. A wacky templater. This will replace any dollar token, dollar some word, with the value of the same named scalar in your current scope. Everyone follow this expression here? You're grabbing a word, okay, dollar, then some word token, and replacing it with $1. But $1 is being evaluated. Okay, so basically, $1 is going to be what's grabbed, and then you're going to evaluate that again. That's $foo. And there's a $foo in your scope, then this token here is being replaced by the value of $foo. It's a weird little templater, but it does work. Now, what about /3Es? Are you all adults in the room? If you do that, you should be coding in brainfuck. If I ever see a triple E on an S operator, I will. You don't know what I'm going to do. Okay, now we get into some much meatier stuff. So hold on to your hats. Eval string for speed by pre-processing sort key extractions. Ever know about sorting and the algorithm theory? Sorting is famously n log n. Basically, that's an average, and I'm not going to go into any details of different sorts, but typical sorts are n log n, which means as you grow the amount of sort data, the sort work grows by the order of n times log n. Okay? Everyone follow that? When you have multiple key or complicated key extractions, you could factor out that overhead because you're sorting every time you access that key, you're doing it n log n times. And that's a lot of extra work. You can reach a big speed up if you convert that pre-processing into generated code. And if you're doing a lot of sorting on different data sets, it can really give you a big speed up. And the thing, the factor out code will be order of n, not n log n, because you're doing it linearly on all the data. Sort Maker, a module I wrote, real quick back thing, I came up with the algorithm for doing Sort Maker, sorting with string caching back one of the early Perl conferences, and I co-wrote a paper with a guy, and we won best paper at this conference, and there's only one reason we won best paper. Damien Conway didn't enter one that year. Previously, I heard that they were reviewing the best papers for the award, and they couldn't pick between two papers, and they were really stuck on which paper was which. They were anonymously entered, and they found out that both were entered by Damien. So he decided not to enter and let me win, which is cool of him. Okay, so there's 4 styles of sorting that we can generate. Plain, which is no caching. That's your standard calling the sort operator. But this is still useful, this module, because if you're not really cool on how to write sorts, which are doing different things, you can describe your sort and it'll generate code and you can learn how to do it or just use the code. Orcish Maneuver is when you have an or equals into a hash. So you're caching the keys that way. Okay, that's why it's Orcish or cache. Bad pun. I don't know who invented that. Schwartzian is invented by our own Randall Schwartz, who's here this week, and he caches the keys that are extracted in an array. And the final version is the Guttman transform, which I told you about the article or the paper we wrote, and that stores the keys and the original data in one single string, and you just call one compare on the whole thing, saving you a lot more overhead. So it's the fastest one. But we're going to show how to generate the Schwartzian transform. It's most illustrative of code generation. So regular code that you're executing now will be in yellow. The code you're generating in various places will be in green. Various amounts of data in blue, and random other stuff will be in red. So here is how you actually call sort maker. Mix sorter is the main subroutine you call. And we're calling an ST Schwartzian transform, and we're adding an option saying we want a reference output. Basically, we want an array reference for the output, not just a string array. Okay. Now, the first key is a string. The code extraction is just key 1 and a hash. And we want no case. We want basically no case checking. Okay? And I learned today that from Sawyer that I'm using UC. I should probably switch it to FC. Maybe one day I'll patch this. Okay, the second one is a number, and it's a code just granting out a key 2. This is a little demo thing, and it's a descending order. You'll see why that happens, okay? Now, here's the actual code being generated. And notice it has the map, sort, map. If you know the Schwartzian transform, that's what the famous thing. The other transforms also do map, sort, map, okay? You map the input, you sort on that data, and then you map the output. It's one long expression. So here is the second comparison. Notice that it's got the spaceship operator, which is the number, and the B is left and the A is right, because we said descending. So we reversed the order of the comparison. And then, I'm going, fine. Now, here are the 2 key extractions. Basically, the original key goes in the $_, or it's coming from $_, and then the original argument is going in the $_, and then we get key 1, and then we get key 2. But key 1 is uppercase because we said no case. Let's go forward. Okay, there we go. Now, here's code that's actually doing the generation. Okay, so basically, there's the main subroutine, and the argument's coming in. Come on, I'm hitting the wrong key here. Okay, there we go. So now we're declaring 2 arrays, all the comparisons and all the extracts, and we start with an index of a string 1. This is for indexing into that array. And it's a string because I'm generating strings. When it's compiled, it'll be converted back to a number. So it says, why don't I use a number here? Well, because I'm actually building up strings. And I could have put a number here where it worked too. But it would be an extra conversion. Why do it now? That's what stInd is. So here I'm looping over all the keys. We have 2 keys coming in. And here, I build the comparison. So you see A, notice I backslash the A there because I'm not looking at the actual A, I want text $A. And the end, stInd, is a variable that's being used. That's the 1 on both sides. And then B is over there. And I use the CMP comparison operator. I default to a string. But look, if it's descending, I translate A and B to B and A. Now I know this thing up here doesn't have any A's and B's other than that, so this works fine. Modifying the code that I'm using to generate. It's a neat little trick. I could have done this a different way by having 2 different possible lines and tested that and done if else. This is much neater. And then I switch compare to spaceship if it's a number. This could have been done with a $CMP variable and maybe a question mark colon kind of operator, but I was in the mood to do substitutes, so I did it that way. Just as equal. Now I bump the index for the next key. Remember, it starts at 1 because the 0 location is the original value we're sorting. Location 1 is the first key, location 2 is the second key. And then I basically store the compares onto an array. Now I build up the extract code. Remember, it's still in that loop. So the extract code, is all this green is actual generated code, and I have a token called extract. And there's the UC built into it. And I get rid of the UC if it's basically, unless it's a string and it's no case. For the number, I get rid of the UC. If it's case sensitive, I get rid of the UC. And that's here. And then I substitute the word extract for the actual key to get the code. This stupid thing should be a regular dash greater than, but Impress converted it for me, and I didn't see that one. See, the ones above it are correct. I kept doing that. I couldn't figure out why. Okay. And now I just basically chomp that last one just to make it look pretty, or get rid of the new line in the end, and I store all the extracts. So basically we're looping, we're building up compare codes, or building up extract codes in 2 arrays. Now I join the compare codes, and I join them with pipe, the OR operator. I put a couple of tabs in there and a new line to make it look pretty. But basically, it's comparison or comparison or comparison in the order you give it. That's the order of the sort. The extracts I just join with commas, and a new line also to make it look a little pretty, because they're basically just being an array. Now, if the input is going to be a reference, I have to dereference it. And we're not using an option in this example, but if it isn't a reference, then I use add underscore as itself, or I just dereference the first location and add underscore. Now, because we're doing a reference out, as we turn on for the example, I am storing an open bracket and close bracket, the 2 brackets. And if there was no reference out, I would have used 2 null strings. Now here, as we actually build the actual code, look at the map, sort map, just like we had before. All right, there we go. All right. Now there's this compare source, and there's the extract source. Okay, so the map is basically, the first map here is getting the results out of the sorted array. We sort with the compare source we built, and the map of the input is, again, the first location is the original data, the extract course, and then return open bracket, that's if we want to return a reference, and return close bracket there, and the input is going to be add underscore, or it's going to be dereferenced at the first location of add underscore. That's generated code. And there's a code that's being generated. The rest are all variables that are being interpolated into the code. But there's more. We're going to eval string for pre-parsing a template. Everyone following along so far? Any quick questions? We'll have time for Q&A afterwards. How's my timing?
Just past half.
Okay, that's good. Okay, we're looking at template simple for recursive Perl code generation. This is a little more complicated. So rendering a template, who's rendered templates with modules? You know, most of you have done that. Okay, so you have to parse a template every time you render it. That's a lot of overhead. Some templates simple, and some templates can compile a template. They pre-parse it, and they generate Perl code or some other technique. That means parsing the template, generating Perl code that will render it. So this is done one time, and you can call it many times. So you have a library of templates. If you pre-process them or pre-parse them, you'll save a lot of time rendering all your code, or rendering all your text. The template simple's compiled mode is 4 times faster. It's actually one of the fastest templators you're ever going to find. So take a look at it. Here's a short template. Okay, so we use the module, and we just declare it, and we assign a template. And the template is this blue stuff. Okay, now anything with a single word is a scalar variable for replacement. Start and end mark what's called a chunk, which is basically a chunk that will be matched onto a hash for replacement by its keys and the scalars, the foo and the bar. Okay? So we have a family chunk here, but also the whole thing is an unnamed chunk. We'll talk about that a little later. The top level is an unnamed chunk, and then you can have nested, recursive chunks all you want. Okay? Everyone understand this right now? These are the scalar variables being used. Okay. Now here's the data I'm passing in. So foo, bar, Larry, Wall, foo, bar, Randall, and foo, bar, Damien, and Mad Professor. And it comes out, notice here I'm dereferencing it. Template returns scalar references all the time because it's faster than passing the strings on the stack. So we do a lot of scalar referencing inside of dereferencing. Here's the output. Larry is a Wall, Randall's a Schwartz, and Damien's a Mad Professor. Is that correct, Larry? Okay, you're a Wall. Okay. So here's the generated code for that. So we have anonymous sub, data coming in, and this is the main output variable. Now here's an interesting thing. We assign the scalar data into the array data, and we loop over that. Basically, because template simple allows you to pass not just a hash to match in a chunk, you can pass in an array of hashes. And it'll just loop over that array. So there's no loop construct in template simple. You just pass an array anytime you want, and it works. So this code here, coming up, wait a minute, back. Notice I have data here and data below. There's different scopes. And there's a reason I keep the word data there, because we're going to be nesting and recursing. And the code is not recursing, but the logic is recursing. So we're generating deeper and deeper code, and I want to use the same code everywhere, so I had to keep the same name everywhere. Okay? So here, as we see if the data coming in is an array, we just push that data onto the data array, and we go back to the loop. So basically, I'm saying a single thing here, just do it. If not, it's an array. Push it all back onto the original, this outer at data array. That way we can just keep doing things as if it was a single one or a multiple one. It makes no difference. But that line, this bit of code you'll see several times. Now we are doing the top level unnamed thing. We have the title, and we have basically the data is a hash. We'll put it in title. We have a hash there. If it's no hash, it will use the data as it is. And there's a new line which is part of the actual template. Now we're descending into the tree. So the array data now is what's under family. Title is a top level, family is a list of arrays, a list of hashes. So here, data equals, you're doing the same wild data, and the same data equals shift data, and all that. This is the same code we had in the first level, but we're just generating at a deeper level. Now we build the actual chunk. And again, it's either we're using the raw data or it's, in this case, family new line tab is the raw text from the template. They were penning that with the thing in foo inside the data, and then isa and the thing in bar inside the data, and then a new line. We're breaking it up into scalars and text between scalars. Here's the Perl that generates that. Now, this is going to be interesting. Now, the main routine is called compile chunk. The top level code body, you see here, I'm passing in no name. The first argument is no, because it's the top level. I don't have a name yet. The included is actually the data that the template that's been rendered with include files. You're allowed to say include something, so that's all been done before. And then we have a single tab, which is the current indent level. So here's the entire output. My data equals the @ underscore. You're declaring out the code body, and you're returning /out. That's it. Notice there's two different /$outs. The first one is just declaring $out in the generated code. The second one is returning $out, but you need 3 backslashes there. The first 2 are returning 1 backslash, and the third one is to escape the $. And it's all in one double quoted here doc. I said before that we return in template simple scalar references. So that's what this is doing. Now we get to the actual work. So compiled chunk takes a chunk name, the template, and the current indent level. Then it sets up a data initialization thing, which is if you have a chunk name, then the data is going to be what's in the data named chunk name. Now mind you, chunk name in this thing is a data variable we're using right now. It would say data point to families we saw earlier. Okay, but the data itself is being escaped. So chunk name is not escaped, data is escaped. This will generate data point to family, because family is the name of the chunk we put in earlier. Everyone following that? Okay, I see nodding heads, which is good. I don't see shaking heads. So here we assign the data init, whichever, in this case would be data point to chunk name, and we're assigning that back into the @data. Again, we're escaping things as we go. Notice there's all these indents on the left. Those are all single tabs. We're looping over the data like we saw. And this is the same code we saw earlier. We assign single data from the array, and if there's an array, we push it back on. So that's that generating code for that thing we saw earlier in the actual code. And then we bump the indent to a higher level. So I want to keep the nested code indented nicely so it's easier to read and figure out when you're making mistakes. Now, parse name and parse body are results of this regular expression. And it should say chunk name and chunk body. I realized that today. It's a naming thing I left in the code that should be changed. So parse name is the name of the chunk, family in this case. Parse body is the actual template inside the start and end. So we're grabbing those out of the current template by using this very fancy chunk RE expression, which is not being shown. Now once we have that, I get the left and the right index of the chunk by using, who's ever used @ minus or @ plus? Okay, they're neat arrays that give you the indexes of all the things you've matched in a regular expression. The minus gives you the left location of a matched part, and the plus gives you the right location. I want to look at the first one because I want to get the parse body out. So now I know what the left side and right side of the chunk is. I call compile scalars on the left side. Everything before a given chunk is only contained text and scalars because I'm looking for the chunk in the irregular expression. So I basically compile the scalars for that, append it to the code, and the text I'm passing there is the template that I got passed in, starting at 0 up to the left index, just before the chunk starts. And I give it the indent. So the stubster is the part that's before the currently matching chunk. Then this subster deletes that and the template because I mean, the chunk, because I already have the chunk in parse body. This basically just saying assign to the template starting at 0, the null string, and it's going to end at the right index, which is the end of the matched chunk. So basically we're chopping off the template, plain text and scalars, chunk, text and scalars, chunk, text and scalars, chunk, in a loop. And then here we recursively call. Remember you had that regular expression before with the E? This is the recursive call. That way, if there's any more nesting chunks, we will then process those in this thing. The chunks are marked by start and end with the same name, so you can have start family, blah, blah, start children, end family. This supports that. And we're basically passing in the name we just parsed out, the parse body, and the current indent level. And it recurses back up to the previous code. Then we have maybe trailing scalars after the last chunk, and this handles that. And then we chop the indent because now we're done with that indent level. We're backing up. And then finally, I'm back here. Oops. And here, we append the last indent with the brace. That's the closing brace of the generated loop. So everything looks pretty. I like pretty code. Okay, we're doing well here. So here's some tips on generating Perl code. Make your generated code accessible by a method or sub. You notice in both cases, I had either a method to print out the template generated code or a sub called sorter source, which allows you to print out the generated code. Very important when you're doing this kind of stuff. It's useful for debugging. I mean, what did I generate? It's blowing up in my eval. You won't know if you look at the code. You have to do that. And it's also useful for cutting and pasting. If you write a sort routine you like and you need it, why call the compiler or the sort maker in your code? Just cut and paste it and use it in your regular production code. Run it offline and put it in there. So that's a good reason to have access to that source. I like to format the code to be readable. And you've seen lots of people. I've seen generated code. It's just squished together with no white space at all. I mean, what's the point? The white space doesn't slow you down, and it makes it easy to debug. I think it's very important. Again, for copying and pasting, use dot equals. Who has never used dot equals? Good. That's a good audience. That's one of my favorite operators. I use it all the time. It sounds so simple, but amazing how many people will say this equals that dot that. I mean, it just you see that a lot in newbie code. They don't know about the plus equals, dot equals, and all those operators. I like here docs, as you saw a lot of here docs. I like them on the left margin because when generating code, that's what you're going to see. Whereas the new indented allowed here docs would not be what I want. I want to see what's on the left margin. But I like the idea of the indented ones, but I don't mind having the token on the left. I'm used to it. Now, this is the most important slide. Be careful about what you escape in the generated code. You saw there are times I escaped things and I didn't escape things. I escaped the code that being generated when I needed to, and I kept variables there when I needed to put them into the code. And that can be really tricky because you forgot to do this thing or you didn't do the right thing there. It's definitely the thing you have to focus on the most. Matter of fact, there's one piece of code I showed you. I could have put the initial part in here docs with single quotes on them and not have to escape anything. Then the variable with the dot operator, and then the trailing part with here doc that was also single quote escaped. And someone suggested that idea, and that's actually a good idea. So if you have a section when you don't have any interpolation, make that a single quoted thing, and you can eliminate your escapes and make your generated code easier to read when you're writing it. So I was used to escaping, so I just did it, but I didn't think about it that way. And I know here docs can allow you to here docs. You could say here less than quote single quote token single quote. That means your entire here doc is single quoted. The only thing you have to escape, though, is backslash. So I would still have to, because backslash is You could say backslash quote in a single quoted string. Oh, maybe not in here, Doc. Okay, it's possible. But in any case, we have to be careful about that. Generate an anonymous sub with your code. If you're doing anything complicated, you want to make it a sub so you can call it. If you're just doing it in line, what's the point? You have to be able to call it later on to make something useful if you want to get a speed up. And they can call it multiple times in your module, or again, when you dump the code out with the source thing, then you could use it then. And then you could cut and paste and give it a sub name if you want to. But if you're building it into the system, like template simple has it, you could just use the module template simple, compile the templates and use them. I need anonymous sub to get at that. Named sub makes no sense in that context. And that's it. I want to thank Damien for helping with the presentation. And we have questions and maybe some answers. So, any questions, comments, heckles?
It does make sense to have a named sub that you're generating, but it depends on what you're doing.
Yeah, but what scope is it going to be in?
Well, sometimes you want to generate a method for some class.
Yeah, but if you wanted, then you put a package in front of it. You could do that. And you could declare you could generate a package name, package command, and then yeah, you could do that. If you want to do it, generate a method, that would make sense. Anything else?
Just double check the single quote here, Doc. The backslash is not special.
Okay, fine. That's good to know. Any other questions, comments? Large sums of money? No large sums of money?
My only comment is that people should use eval in the /e instead of /e.
What?
Use the keyword eval in the.
Oh, yeah. He mentioned this. Okay. Yeah, you mentioned this last night. Here's another alternative thing. If you want to do a double E on substitute, Devin said, use a single E, but in the expression, say eval on the string.
That makes it clear what you're
It's a little clearer, but you shouldn't be using double E anyway. Yeah.
if you really feel you must.
Okay, if you must use it, yeah. But it's like I showed you that wacky templater. I would never do that. I don't recall actually wanting to do double E. But mind you, the template simple is not doing double E. It's recursively calling E. That's the part that's fun. Yeah.
I've got some code where I pull the package name out of the config file and then do an eval, but I'm doing eval use where you're doing I mean, I understand the difference between use and require, but
Well, the difference use will basically call import. And if you need import, if you're doing methods, then you don't need import. I mean, if you're doing an object module, you should never need to use, at runtime, you don't need to use. I've done that where I do polymorphic modules, like which codec am I using? And I just I do the same thing we showed you, eval require class. And I just, I use the class name then to call the codec. They're all the same. I call class name point to new and create that object and use that as my codec. And that comes from a config file.
yeah, like each one I could call in has the same function.
Right. That's polymorphic. That's one of the really nice things. I love doing it.
Eval use also won't work in Perl 6 because imports are done lexically. So
What?
you would import it into the eval and throw it away.
Larry, I couldn't hear you. Larry, yell loud. I want to hear what you said.
Eval use doesn't work in Perl 6 because when you import in Perl 6 with use, it imports things into the lexical scope, not into the package.
Oh.
So it would happily import it into the scope of the eval and then throw it away.
Oh, okay, yeah, okay. But we're not talking Perl 6 here.
Aren't we though?
I mean, eval is useful, as I showed, but it's like you have to be disciplined, you have to be careful, and you have to make sure it's what you really need to do rather than, if you're generating a method on the fly or you're generating something for speed up, all these things are useful. But that eval system sleep 5, that was an eyeball burner.
Wait for the macros.
So, any other questions, comments? I mean, what's our timing? I have 10 minutes here, or you can go home early. Your vote. That's all. Stay here, go home early. Go home early? Okay, thank you. That was more fun than I thought it would be. Thanks for being here. I really appreciate it.